Okay, hello everyone. Welcome to another Wolfram Language Design Review, back to back with our previous one. This one is also for version 15.0, and it is about data models. And we had talked about Tabular. We are about to talk about time and event series. We had started on this last time, but we need to push further. So, all right. Now supports named components with transformation functions using names. What does that mean?
So we can't, it's a little bit strange to use column for components. Like when you think of a time series, you think of it having different components. Think of a ECG or
No,
financial
okay.
data. Okay.
Yes, it's not a column because it's not a tabular. It's a component.
Right. Right. So we call them
Okay.
components.
But
And
don't we have a lot of functions that are called column blah blah blah?
yes,
And
meaning
how will they work on time series?
they will use components. So the analog, if you think of time series as tabular, it will have a time key column.
I
And
understand
then
that, but I'm asking a different question. I'm asking if we have, look, in tabular,
mm,
okay, we have all these things
yeah,
for wherever it is, construct
transform.
columns.
Yeah. So
Yeah,
there's two of those.
right. Well, we have more than that. Cast columns, pivot to columns, all this
True.
kind of stuff,
True. Yes.
right? Okay, how does that relate to time series?
I mean, we're gonna have to, so
What can I say something?
yeah,
Huh.
right. Yes.
It relates to time series and that every time series has a tabular associated with it. And basically that tabular has a time column, and then all the other columns are the component columns.
Okay, so if I take this time series here,
Yep.
and I say tabula of that time series,
Yep.
I see.
Boom. And so so basically all those tabular commands you were looking at work on the following principle. They do this tabular time series exactly as you did, do the operation on the tabular, and then there's a direct conversion back to time series from the tabular. It's not exactly that, but it's pretty close to that.
Well, it should be that should work.
Well, in this case, it'll work, yes. But if the time column has been affected, some special stuff needs to be done.
Okay, but then if it's a question of, I mean, the truth is, I'd be perfectly happy if I'm monkeying around with components in a time series. I'd be okay thinking of that as a tabular. I think it's okay to think about that in terms of columns
Yes, and I
because,
think that's how we want to encourage people to think about it.
okay. So time series has a time column, an event series has an event column. Is that correct?
We
They both have a time column. Uh, then there are sort of values.
Can I ask a question about this? Because data drop has a mechanism for this. Okay, a data bin has the notion of a timestamp. Why don't we use whatever data bin, which I now forget,
I was
uses
going to
for
say
that?
a big difference is the event series can have duplicate entries
I understand.
and the semantics
Well,
of them.
for what it's worth, we call them timestamps
Yeah,
here.
that was a possible name I had thought up too, was timestamp or
Oh, you mean what the tabular comes up
What
and
the
look
column
like?
is called,
Oh, I see.
yeah.
time or timestamp. I don't know. What other opinions do we have about this? I mean, right now,
Well, there is a confusion right now that has come up actually between time as the column name and time as the data type for time object.
well, that's a good reason to call it timestamp.
Yeah. And I think we discussed endlessly whether it should be singular or plural, and I think they should be singular because the timestamp refers to the
Yeah, it's a
element entry.
collective. Yes,
Yeah.
I think it should be called timestamp. I think.
Okay, good. I like that.
Um, I think. That means that the documentation for time series has to say it is data with a series of timestamps.
Yep.
So what about backward compatibility? How was it called before?
It wasn't
have a
called
name.
before.
Doesn't have a name. Because it never had
The only place that had a name was in moving map, which we will continue as times, which we will continue to support.
But there were properties to extract times
Yes,
and
there's a
value.
times property, which
could perfectly well be timestamps.
yes, we can make both work.
You can make both work, yeah.
Okay. Yeah, I remember having this discussion, and I think I was defending time just because it's shorter, but
Yes.
it's fine.
I think
Timestamp is fine too.
times plural is very obscure.
Mhm.
Timestamps seems less obscure.
Yeah.
I think. Roger, do you have any comment on this?
I think timestamps is fine. You might want to use it sometimes as a variable, right? So you're going to type it in, like in one of those tabular transformation functions.
Yeah. I think it's less obscure to type in timestamp than it is to type in time. Yeah, and then timestamps plural becomes the accessor, which it also is in this case here. Somebody, by the way, should please take a look at DataBin and make sure it's compatible with the new time series mechanisms.
Yes, we have been discussing with Bob
Okay, good.
about this.
Okay. Okay.
So last time we looked at the typesetting.
Did we let Jeremy escape, or is he here?
I'm here.
Okay. What is the embedded? I don't understand. What is a tabular? This is different from the look of a tab. I'm confused about what this is.
Well, we haven't changed. We haven't gotten the new change which you suggested in the prototype yet, so you won't be able to see it.
But I think that the embedding is with the view, so that was the idea.
So the view is now called, Jason's changed it. It's now just
Preview.
called preview.
Mhm.
Okay, but what's all this stuff here? Well, did we already solve this last time?
We solved this last
We
time.
saw that
Yes.
this,
Okay, let's
we have
keep
it
going.
working on
And
prototype.
It's
Mhm.
just not in the prototype yet.
Mhm.
So
Okay, fine. All right, okay. So what are we looking at here? We're looking at all these new functions, is that correct?
Yeah,
Right.
Okay, which we started looking at last time.
Exactly.
right.
How far did we get? So we were looking at these time series events, right? With time
Mhm.
series events, like image measurements or something, has various kinds of things that it can look for. Is that correct? We looked at this last
Right.
time.
It had a number of named type of events.
Yeah. I mean,
We
what happens
actually
if I want a function?
I think it should have a fun case.
exactly. We worked on this morning and came
And
up with
if you-
some ideas.
we
The
actually
page has-
forgot to tell you to update documentation.
Ah,
Sorry.
okay. But so how does the function work? Does it look for successive? Does it look for a run of? Well, what does it do?
It finds things like crossing, the maximum, local
No,
maxima.
I know
local
what that does, but if an arbitrary function, how is an arbitrary function working on the data?
Well, it has an argument specifically to specify the function for which you want to find the crossings, the minima, etc.
Yeah.
Oh, I
So
see.
our
And then
proposal
it
is you
uses
give it
those
a
same ideas again,
Mhm.
but on some transformed version of the data.
Exactly.
exactly. And I mean, I wanted to do something like win event, but we can't do that because we don't have a good way of expressing, self of t or something like that. So
Well, it'll
we
be
have
usually a hash sign. It will be usually be, it's a thing that when event would usually be, hash is greater than 7.
no win event. See, win event is we use the
I
variable
know
names
variables.
from
I know
right.
that, but I'm saying, but
Yeah.
for this thing, since there is a time series, I mean, what I would assume is that it will be the analog of when event, and it would say hash fish size greater
I
than
see.
fowl size.
Yeah, because you want those to be a function of time, right?
No, we're trying to get events, right?
Yes, we were discussing this, and,
Yeah.
and we concluded that minima and maxima were a problem. How do you express
Yeah.
you want the maxima here?
Well, I mean, this is very similar to the temporal logic stuff with this sustain, whatever it is, right, Roger?
Not really. So the way you can view those temporal logic operators is that they're like filters, okay? So they're going to be true over some interval.
Yes.
Um,
Okay, so what we're trying to do here is we got a wiggly function, and we're
yeah,
trying to say what points are notable on the wiggly function.
right.
Yeah.
But we're
And
trying to have like low dimensional, like zero extent type events.
I
And
understand, but so
the
how do we
temporal
do that
logic
for a
is
function? Yeah, okay,
Well, in when event, we can just use the derivative to say get a maximum.
okay, but I mean, let's say we have some function here.
Yeah.
Okay. Okay, what are our functions for operating on that function? If you get what I'm saying, that would give us this. So we might say, for example, how do we get the local minima of that function?
well, it's hard, but find minimum would do, would find something.
I know, but what we could have a function that just gets the minima, the local minima. How come we don't? Probably should have such a function.
Yeah,
I mean,
given a finite interval, we could do that, but we just have never defined that.
Right. Okay, I'm suggesting that. But okay, but then that will be an example of how you get. So, crossings and minima, and I think you've got some other things here. Well, that's what you've got. You've got
That's
crossings
it.
and
It's
minima.
crossings and minima and maxima. Yeah.
Yeah.
Yep.
It's crossings and extrema is what we get.
Right.
Okay, but the point is that you might want to have a pre-processing step where you modify the function before you look at its crossings. You might want to modify look at the extrema of function plus, time squared or something. Right?
We want this to
exactly.
work for noisy cases, like fine peaks. So it's not just a smooth case.
Yes. Yeah, so that's something beyond just maxima and minima.
It is.
Right. Right.
Yep. That's why there is the false line specifying a scale, which is one of the parameters that fine peaks would take.
I have to say, I would say local minimum, local maximum. I think it's much less. I think it's unclear if you don't do that. Making sense?
Mm-hmm.
Yep.
Well, I don't know why you don't just have a syntax that has some. Let's see. Can this take multiple ones here? What's the fun?
What do you mean, multiple ones?
Well, no,
The fun is like the function. So your fish size and fowl size would just be the function would then be fish size minus fowl size.
Right.
Okay, so what's wrong with why isn't that general? I mean, why doesn't that allow if all you're doing is I mean, we don't know of any other criterion other than these crossings criteria and so on.
Well, the crossings are easy to handle in a function, yes, but the maxima.
No, but I don't understand how we would use a function. I mean, okay, what you've got here is that the fun here is a pre-processing function for the time series before it is, maximum analyzed, so to speak.
Exactly. And that additional condition in that fourth argument is a condition that you test once you find a thing to see whether it actually is to be included or not. And that's run on the original time series too. And when event has a condition mechanism, which is very important.
Okay, but so wait a minute. So this was the thing you just added was the fun third argument, right?
Right, exactly. Yeah.
Seems fairly reasonable to me. I mean, the only thing I wonder is if there's any other way you're going to need to use those arguments, but I don't think so. You can always decorate the crit argument if necessary.
Yep. Yeah, we can extend the
Yes.
language to specify events.
Right. Okay, it looks reasonable to me. All right. Event series accumulate. We looked at that a bit last time. I
Right.
mean, where is the smoother that takes an event series and just sort of
It's not on the list here. We got to define that. I mean, we have, if you want to look at prototypes for that, you could look at smooth date histogram, or you can
yeah,
look at smooth histogram distribution.
okay.
But it's not the
But I
right
mean,
thing right now, but if you want to just see what they are. Smooth kernel distribution, it's the
yeah,
same
no,
thing.
I know. I'm just thinking about what is this? I mean, basically it's a smoothed event series. I don't know what you do to the event series to smooth it.
These are, I mean, it's a kernel method, so it's basically a sum of
No,
exponentials.
I know. I understand how it works. I'm asking what the
Uh,
function should be. That
all right.
basically what it'll be is something like, of
But
the
what
event
comes out, I
series
mean, what comes out though
is a
is a
time
time,
series.
right, right.
Right, and it has a kernel here or something like that.
Yes.
But I'm just asking.
Or I think what you have first is sort of the kernel size because it tells you how much you smooth it. And then if you really want to, you can specify which kernel to use too.
So it's something like this: event series smooth, which then comes out with a time series.
Right. Yes, it's something like that.
An event series accumulate also comes out with a time series
Right.
with jumps in it.
With jumps in it.
Okay.
I think both are really quite
Useful.
useful.
Yeah, they're both useful for sure.
Yeah, this is a little bit raw. This is very raw documentation right now. But they're examples. Yeah, as you can see. And you could imagine that you accumulate on some other value than just the sort of the presence of an event. You know, like a queue is a typical thing. Look at, you can exit the queue and enter the queue.
I
Can
see.
go up and down.
So it returns cumulative values of component as a time series. So it's a single component time series at that point.
Right. Right. Actually, we might have to think about that for a sec. What it should do.
Well, I think that in the third case, it's eating, tabular rows basically, aka associations, and it's combining successive associations, I would assume.
Go share that last one. Produces a
Oh,
multi-component time series.
well, so the last one, yes, so you create the multi-component, just, but you're right, you start creating just a single component, and then you can extend that creating multi-component time series. And F, it's kind of a narrow field for the time being because you can think about like the cumulative plus kind of total being the accumulate, but also having a minimum or the maximum. So having an idea of a running maximum, running minimum. So not, I mean, like I don't see it right now as an arbitrary function, but certain selection of functions that would allow you to kind of move along and find, the value for I see it as for the window up to the current time, right? So maximum up to the timestamp, and then you keep going a maximum up to the timestamp and such.
I'm not understanding that. I mean, so
But so how accumulate works? It accumulates consecutively, right?
So
For the values.
we're missing a few functions, Stephen. So we could have a cumulative times, we could have a cumulative max, we could have a
Max.
cumulative min.
Mm-hmm.
I
You see what
think
I'm saying?
the general case here is what we could call products, which are our flat functions, functions that take a number of elements and return another element of the same set,
What?
like plus and times.
Yeah, but they need to be.
Like, I mean, string join takes a bunch of strings and returns another string.
Yeah, but this is not. You need the whole sequence, like accumulate. See what I'm saying? It has all the partial sums.
Okay, I'm
Yes.
confused.
It's
We've
folding, yeah.
got an event series, and it has many components.
Mhm.
It has timestamps and components.
Yes.
Yep. Right.
Uh,
So this is I think we need to discuss the difference between the time series with one value and multi-values. I think that's
Yeah,
what's confusing
that's-
Stephen right now.
But can I
Right.
interject just on a slightly different angle? So
Mhm.
the event series accumulate will also work on time series, but it will treat time series as a series of events. So basically, if you would look for, say that we have the single component values for simplicity, it would, for example, find the running maximum. So for each, timestamp, you will get the maximum of all the values up to this point. Right, so that just like accumulate gives you all the things in between, and so so in this case we call it event series accumulate because it treats everything as an event, and it doesn't care what's in between. It just kind of accumulates just the values.
well, it's called
in that way.
summation going to integration. You're basically saying that event series accumulate applied to a time series gives the integral.
No,
or
that's what I'm saying, that it does not. That
Well,
it
it
looks
should.
as a time series as a collection of events.
But how does it do that? What's the granularity of it?
But then accumulate would look at the time. If you apply accumulate directly to time series, then that would do what you're thinking about.
Wait a minute.
It's some sort of it's some sort of a Riemann approximation in which you
but
you take the
does
values.
it have granularity? Does the time series have granularity? It does, doesn't it?
Yes, in two ways. It has granularity in the timestamps, but it also has granularity as to where the timestamps are placed.
If it's evenly spaced timestamps.
If it's evenly, but yeah, so right, exactly. So if they're unevenly spaced, then the granularity is local.
I understand. But so I personally, I think that event series accumulate applied to a time series is hokey. And I think you should, extract time series events first. I think we're just going to get ourselves in trouble because it's like saying, is it the same function that does a sum and an integral? And the answer is it isn't, because there's a dx type thing that we're not taking account of. Do you see what I'm saying?
Yes,
Mhm.
I think it's a mistake. I wouldn't try to
but
shoehorn those two things together.
Yeah, I agree with you. I think it would be clean. Because
Well, we
I
can,
think we run into problem when we when we confuse semantics a lot. It's very hard
Yeah.
to.
Right, but I mean,
well,
go ahead.
you can always do event series of time series to
Exactly.
convert a time
Yeah.
series to event series.
Exactly. But
Yes,
then
and then you have a bunch of discrete points, but that's a very different kind of a thing. There's no continuous function that you're dealing with then.
Yes, you're saying I want to reinterpret this in a different way. So you're
Exactly.
explicitly doing it's an explicit cast, basically, versus
Mhm.
Yes.
implicit.
Yep.
Yes, but now with respect to event series accumulate, I think that's fairly straightforward. I mean, okay, you're saying, I'm sorry, this is time series events. No, wait a minute. Event series accumulate. So this is applying F. This is extracting a single component, which you could otherwise do how? What's the best way to change a multi-component time series into a single component time series?
You do E series part of all comma com,
Okay.
just like you would with tabular.
Okay. So then, let's see. I don't quite understand. So this F there, that's different from the fun that appears in time series events, which is a
Correct.
preprocessor
Yes.
needed before you do the chopping.
Correct.
Whereas here, I don't really understand why this F isn't just, get out a time series. What's the point of the F?
The F, so we could have max, min, plus, or product times. So you could have, like a running sum or running maximum or running minimum.
But that's not what it says here. Cumulative values of functions. So basically, this is a fold, is what you're saying.
Yes.
Yeah.
Yes.
And
Yes.
why exactly isn't this
Or
called
a fold list. Fold list.
Fold list.
Yeah.
Because the original kind of idea was to accumulate the counts of the events. So that's the name came from the first kind of iteration of the function. If we're
Okay.
now expanding this and you think that the name is not corresponding to the more general case, then we could think about different
Well, I
name.
think if we're going to do the general case, we should have F as the first argument, eliding the first argument if you have just a single argument.
Yeah, but I kind of agree. A fold, what we really want is a fold list, or a map reduce or something like that, where you give both functions, because the number of functions you can use there is so limited.
Mm-hmm.
Well, so wait a minute. So what does that mean? That for the event series, you're basically computing the fold list of the event series.
Yeah.
Mm-hmm.
Yeah.
So why aren't we just making fold lists work on an event series?
That's an interesting idea.
I have
I
to
mean,
say that
mean
it has. Sorry,
mean
I
will
think
work
we
on an event
the
series,
super
right?
common case is just count events, right? That needs to be super simple. Don't you think?
Yes. Well, counting events. And
Cumulative counting of events.
yes, which is why we could potentially have this function without an F there at all. Just not do the F, not support the F in the first version.
I guess.
Maybe it should be event series count or something like that. Really simple.
It's cumulative. I mean, it's
No,
If you just do counts, it's confusing because you may
Mhm.
think that this is counts per your timestamp. And this is event series, so we can have multiple events at the same timestamp.
Right. But why not make fold list as a separate thing? Why not make fold list work on an event series?
Yes,
I
this
mean,
can be
I'm
done.
right in believing that mean will work on an event series, right?
Yes.
Mhm.
Lovely. That's lovely.
Somehow, I
What
have the
happens if
impression.
I estimate all these distributions? Can I do that? What functions would I use to do that?
I don't think it's going to work at this point yet. So.
Okay. But it would be.
So ideally, it would be estimated distribution, and then you give the data, the time series, and you would give a model. So a distribution with a parametric distribution.
Right. And it would return the association.
With the distributions, that would be, yeah.
That would be very cool.
Okay.
Sorry, I have the impression that fold list on an event series would naturally give another event list.
It would.
But here we were discussing having a time series.
Yes. But you can always
Another idea is having accumulate. It has been suggested that accumulate takes that second argument, f. And that's an idea that has been suggested in the past.
Yeah.
Oh,
Then
a
becomes identical to
generally
fold list.
cumulative function, which would be useful to have.
No, it's the same as fold list.
There's even a
identical to
note
fold
Yes.
in accumulate that says that accumulative
No,
list is
but
effectively equivalent to fold list of plus comma list.
no, I'm talking about something like I thought Jose would meant something like accumulate of list, comma, min, where you
Yes.
do the cumulative min.
Yeah.
Well, that's what fold list does, doesn't it?
Yes, it's just that I think it comes more naturally to mind to use accumulate than fold list.
Can you pull up the docs for accumulate real quick?
Currently, it has only one argument.
It already says here that it's like some kind of shorthand to fold list, and this would be another more powerful shorthand for something that we do very common.
Well, except that it would just be fold list of accumulate of
Yes.
list, comma f is fold list of f, comma list. I mean, it's a bit
Yes, it will
silly.
be fully equivalent. Yeah.
Yeah.
I'm not a big supporter of that. But I mean, having accumulate work on event series is a good idea, and having fold list work on event series is a good idea. Turning those things into time series, given that they have been accumulated, okay, very basic question. How do you turn an event series into a time series? Because it's got to sustain on the left, or it's like list step plot. It's got to decide whether you get what I'm saying? Where the breakpoints
Yes.
are.
So this is actually what I've worked on the last week, so I can speak very, very well about this. So time series of event series, what it does is it takes those, if all the timestamps are unique, there's nothing to do. It just uses what's there. If the timestamps are not unique, it applies a merging function.
Okay.
Okay, and there's an option merging function which allows you to specify what that merging function is. Right, 2 time series. Yeah. And the default for the merging function for numerical columns is mean, which I think is a good choice. And for non-numerical columns, it's missing fallback, actually apply missing fallback. So if there's anything missing, it's ignored. We find the first non-missing value. So it's equivalent to first, basically, but it's a little more, a little more flexible.
That sounds sensible to me.
Yeah, and so I've written code this last week so that it's actually quite fast to do that.
But Rob, what's the default interpolation order inserted?
You can specify the interpolation order. That's done by the resampling method.
But default doesn't insert 0, for example?
No, by default it uses one interpolation order 1 for numerical columns and interpolation order 0 for non-numerical columns.
But in a time series, if I just take a time series and I evaluate it at some unknown time, okay? So let's say this thing at September 3rd, I have no idea what it did here. Did it average over September 3rd, or what did it do?
No, it treats that as a, so what it does is it converts that to tabular column time, okay, and it basically takes it coerces it to the granularity of the time series, okay, and so it takes the beginning instant of that time and uses that.
Which seems wrong. I mean, in other words, if I wanted to know what temperature is it in September in Timbuktu,
Yes.
I don't really want the temperature in midnight the first day of September or whatever.
Yeah, well, we've addressed that, which Jose pushed me to do it, and he was absolutely right. So here we're dealing with that as an instant, but if you put date interval around that, it will actually treat it as an
I would
interval.
do that by default. I think if it's a granular date, if it's an instantaneous date, well and good. But if it's a granular date, look, here's the thing. If it's a granular date and the time series is wiggling up and down during that granular period, you should average it.
But see, it's not wiggling up and down during that time period because we have that. So basically, the way to view the timestamp is so we have that timestamp to some granularity in the thing. So basically, the time series is considered constant for that whole interval of an actual timestamp.
I know. It's constant in the interval of a timestamp, but
Right.
within one day there can be minute timestamps. Okay. What I'm saying is,
Yeah.
you should appropriately average over the minute. Okay, those minute timestamps are giving you an approximate function.
Yeah.
And the interpolation of the minute timestamps gives you an approximate function, right?
Yes.
If you have a granularity of the sub-value, then you should average over the granularity of that sub-value.
So consider for a moment the case of event series. How do we separate the I want a value back from I want all the values from this period back? That's where we started separating the input as a date or input as a date interval.
Okay, but that's a different case.
That's a different case, but in a sense, we wanted that case and this case kind of be related and
But
both
I don't think they
return
can be.
things.
Look, I agree with you. The date interval thing is a great idea for both time series and event series.
Yeah.
I mean, for time series with that date interval, time series is going to give you an instantaneous value back, whatever happens. Event series could give you a list of events, presumably.
Mm-hmm. Right.
I mean, arguably, it should always give you a list of events because, unless you hit it on the nose, you're not going to be able to extract an event.
But we didn't do that in the past. In the past, event series was returning a single thing. So we would break that.
Well, okay, so maybe we can't do that for it if it does return a single thing. If there is only one in that interval, but it's going to break it if it sometimes returns one and sometimes returns more than one.
Well, what we did is we used the same merging function thing for event series evaluation. So the default merging function for event series evaluation is missing fallback. And so that'll choose first, but you can change the merging function to be whatever you want it to be.
And the merging function takes a list of all the values that go into the merge.
Exactly.
Yes.
So
Yep.
you could try, if you had an event series, you could do, event series of time and then, comma association merging function goes to whatever we've supported as an option too in that. And if you use identity, then it'll give you the list of all the events values that occurred in that within that timestamp corresponding to that timestamp.
Okay, so merging function identity will give you that, right? Not lists.
Yes, identity.
Yeah. Yep.
Yeah.
Okay, but so back to time series. So you're saying the merging function determines, given a certain granularity of both the elements of the time series and the query, it will use merging function to decide what to give you. And it will give you a single value.
Yeah, yeah. So for time series, it all give, and we need to have time series that way. We need to get,
No,
we
I
need
know.
to sort of,
I know.
yeah.
So time series needs an interpolation order, right? To determine given that it has certain, key anchor points, key points, whatever, how does it interpolate between the key points?
Right. And that's done through resampling method. And so you can do resampling method goes to interpolation order goes to blah.
Why don't we have the interpolation order function in there? Come on. Interpolation order option. If you have a fancy resampling method, then use it. But I think we should just have the interpolation order option because people understand that. Does that make sense?
That's easy enough to do.
Fine. Okay, let's move on. Yeah. Go ahead.
Yeah, no, I don't have much more to say about this.
Okay, how do you smooth a time series? Just with moving map?
Yes, you would typically use moving map with something, like a mean filter, and things like mean filter and median filter and all those just work on time series.
Or aggregate.
No, but the difficult thing is I've got some sensor and it's wiggling up and down, and I want to get, I want to get a smooth version.
Yeah. Oh, time series. All the filters work on it, like a low
so
pass
you'd use
filter.
you'd use something like mean filter on that
Okay.
to smooth it out.
Okay. I can imagine that we might want a time series smooth function just as a convenience because it's such a common thing to want to do.
A sort of a higher level that you don't have to pick so much in. Yeah. I think you're right.
But usually a heuristic to decide,
Yeah, I mean, knowing all these brands of filters is, it's
What
for
would
the
be
connoisseur.
particularly nice about that is that the time series smooth would then have the leeway to smooth the numerical components and leave the other components alone because they're not smoothable.
Yes.
And with the filters, we don't really have that option to be be technically correct.
Yep.
Let's have time series smooth. It seems like a good
Yeah. How do you smooth maps?
Yeah. It seems like
exactly. So I mean, it only works for numerical columns. I think that would be lovely. You could give it, I don't know if the function comes first, the time series comes, probably the time series comes first, and then the function is an optional thing.
Yeah. I mean, the generic thing would just be smooth the damn thing out.
Yep.
Okay. How do I get an integral of a piece of a time series?
We actually don't have a function that does that, but we certainly have the capability because many methods actually use an integral representation.
I thought about putting something that, integral of time series would just do the right thing, sort of like we have for interpolating function, but I haven't. And I decided against that for various reasons.
Well, what's the variable?
Well, it will have to be TS of T.
Yeah.
Yeah, it'd be TS of T. And see, the problem comes when we have, so if that's multi-component, what does that even mean?
Yeah.
If it's a single component, then it is meaningful. And that's sort of where I got hung up.
Well, I don't understand. Why is there a problem? Look.
Oh heavens, I didn't even realize that actually worked. Okay. I guess that's the central dogma, isn't it?
Yeah.
So
and for time series based on dates, we would have to integrate to deal with T0 and T1 being date objects.
Yeah.
I think so.
Well,
okay. I mean, we might want its own function, time series integrate, but I think integrate would be a nice thing to have.
Mm-hmm.
And then I could imagine also a derivative of the time series at a particular point.
It would return quantity, right? So
yes,
integrating it has a
yes.
DT, which is a quantity.
So here's another question I got hung up on, Stephen, and that is, so when I integrate time series of T, okay, and this is what happens with an interpolating function, we actually up the interpolating order by 1. So is that what presumably you'd expect that for time series as well?
You mean you smooth, if you have piecewise linear, it would end up with quadratic segments.
Right, it would end up with quadratic segments.
I would think so.
Yeah.
I think
which we can support, but a lot of our support for time series based on the legacy stuff. The filters and stuff is really based on linear interpolation.
Yeah, but so it goes. I mean, so we do the best we
But
can.
I think that probably what we should have is something that returns another time series, like, which is a cumulative integral, like rather than a definite integral.
Well, try that with
indefinite integral.
Sorry?
An indefinite integral. I mean, it's the direct analog of event series accumulate.
Right.
Basically, what we have, time series integrate is the continuous analog of event series accumulate.
Right.
And it will be a useful function, I agree. And it doesn't need, somewhat obscurely, unlike an integral, which needs the x there, time series integrate, it doesn't need the x.
Yeah.
Just as that. And then we could have a definite integral form that has some, which I think would be probably better than, it would just have T min, T max.
Right.
And we could also have, well, what about the constant of integration? Starts at 0, presumably. If you wanted something different, you just add 7 to it or something.
Exactly.
Yeah.
It's a bit like d versus derivative, right? So the first one is like derivative -1.
Yeah. It raises the question of time series derivative.
Yeah.
Which we should probably have, but it's tricky because it needs to smooth before it does it.
Right.
Well, I think
it would just decrease the interpolation order by 1.
No, but at the knots, at the timestamps, it would be undefined. Though in some sense, actually, with what we were discussing, if the timestamps have finite extent and it's constant there, we could just use 0 and get away with that and ignore the measure 0 parts where it is undefined.
Yes, but that's not going to work for instantaneous timestamps. Things which have a granularity of a second or something, fine.
Yeah.
I mean, we're learning about the theory of infinitesimals here, so to speak.
Yeah.
I mean, this is why there's trouble with infinitesimals, and because they don't have, it really is an instantaneous value. This is going to be very lovely, guys. I mean, this is really good. We've been waiting a long time for this, but this will be very good. So time series combine.
Yeah, that's that
intersperses times, presumably.
Right. What it does is it takes a bunch of time series, coerces all the timestamps to a common type, which is a big part of what it does. And it does something a little bit like
common type in terms of granularity, or what?
Yes, in terms of granularity, time zone, everything. So it has to be, because otherwise you can't compare the timestamps if they're not the same.
I understand. Is it combine or is it conform?
Well, so first it does that conform, and then so if you have two time series, it combines, making a new component for each column in each original time series, which is why I'm saying it's a little bit like column-wise combine.
Wait a minute, but if the column names agree, it just throws everything in the same column, right?
Well, that's something right now it doesn't.
It needs to do that.
We use an associate. What I did is I set it up to use an association like we did in column-wise combine to avoid key collisions.
We don't want to do that here.
We could have a merging function for that case.
I think we should, because I think the most common case is, I mean, look, I've got this in my own data. Okay, I've got random stuff from steps or something, which would in one data bin full of steps, another data bin full of steps. I just want to combine them. I don't want something standing on ceremony and saying that came from data bin 7.
Yeah. Okay. So I can read, now that I've thought about merging functions more, when I was thinking about column-wise combine, we could redefine that to use a merging function.
Here's why I
similar
think column-wise combine is a little different, and it's important in column-wise combine that you be able to do this. But the most common thing there, I would think,
Is this a join operation?
Yes.
But our capital join.
No.
Yeah, it's
well, it reorders. Because these timestamps can be interspersed.
right. But actually, I came up with when I worked on this more recently, which is like a week and a half ago, and I decided I couldn't get it ready for 15. There's also a possibility for a time series join, and if we have the merging function, they're basically all the same
Okay,
thing.
can I ask a question here? Does time series canonicalize to order its timestamps?
Always. And event series does that as well.
Okay, fine. So I see. So if you were to join, it would just canonicalize.
It would canonicalize, yeah. So there's basically two cases you want it. So what's interesting are the cases that are a little bit like column-wise combined. So remember, column-wise combined, we had that required thing that says I want to use all rows from such and such a
Yes.
tabular. Well, this is an analyzed state. You can say I want to use all the timestamps from timestamp series 1 and say time series 3. But it may, if time series 2 doesn't match, it may not keep
What do you mean it
those.
doesn't match?
Well, if I have times in time series 2 that are not in time series 3 or time series 1, those will be dropped.
Why? I mean, why is that useful? I mean, if I have, I would expect it to just combine all the times. But I agree
that's the outer case, or the union, what I call the union case there. And yes, that probably should be the default. But there may be times when you only want the intersection of the timestamp.
Okay,
so
what? Yeah, okay. I think that will be rarer, and personally, I would just drop down to a tabular approach in that case. And I'm beginning to think time series combined, event series combined make no sense, and they should just be join.
Yes, we could just do join.
Sometimes you have two time series of information for, say, two different people, and you want to align them and keep them in separate columns. We also need that.
Yeah. Well, the join does that with separate columns, Jose. So if you do join on tabular.
But this is exactly the case that I was, ignoring just now. Okay. So let's say you've got a column that's called, steps or something. And one of them is Bob's data, and the other one is Jane's data. And you definitely don't want to combine those. What you want to do then is exactly what we're doing in the, I guess it's outer join in the case of tabular, where we're actually, synthesizing a Bob steps and a Jane steps.
Yep.
You're right. We need that capability.
I think we need that capability. And I think they're using this in the financial stuff.
Yeah.
Like you want to merge in the dividends to the timestamps, but you don't want to make a dividend for every single timestamp.
Yes, I understand. Fair enough. Well, so there's a bunch of join things, and it requires a little bit more thought there.
Yeah, exactly.
But presumably the old-fashioned, I mean, just a raw join, if possible, should be made to work. That seems fairly straightforward. And these promoted, tabular joinish type things, maybe not immediately.
Join. Do we want raw join to just leave the timestamps alone?
Yeah, I think so. I think it's just throw them
they'll all end up being coerced in some way to a common timestamp. But
yes. We should have a little look at all of these. Probably not this second because I'm running really late for something else.
I think a really important thing that, and Jose mentioned this, is how do we deal with, how do we keep backward compatibility for the single value case versus the multiple component case
For what?
for time series and event series?
We have examples further down. Perhaps we can have a quick look. Yes, this here, classic and neo. Neo is just a temporary name for the tabular based. Right. So if you look at accessors, so can you go up a little bit and the accessors subsection? Right. So in the classic time series, this is what you saw before. If we have a time series and we ask for a single value, then we are going to get a number.
Yes.
But you saw before that for a time series that contains a tabular inside, time series of T returns an association.
Yes.
So we need those two behaviors, this number behavior for backward compatibility and the association behavior for the new, more powerful time series.
So why not have the notion of an old-fashioned time series is just a tabular with a default name for its column, for its one column?
Because that would return an association of a single entry.
Yeah. And we do use a default name. If you look at that tabular you made below, it has a value as a default name we choose
but
for
why
that
not?
case.
Why not choose a name that the user cannot type in? That is the thing you get if you type, the old-fashioned time series, function time series of, the list of rules type thing or list of pairs. See what I'm saying? It is a tabular, but it's a tabular with a column name that is a non-typable thing.
I think we are doing that already.
No, but then that would limit users to in some ways, which would not be nice.
Well, if you have an old-fashioned time series, you're going to get. I mean, we're going to need old-fashioned time series. Old-fashioned time series are useful.
Yep.
Right.
Yeah, absolutely.
But the whole point is that the new thing is that every row of a time series is an association. The previous story is every row of a time series is just a number or a list. Right?
That's right. Yep.
Yes. Yep.
Okay, so why can't we support that now?
We can.
Totally. And we do.
We do. We support both cases. It's just that the users have to make a decision of which of the two cases they want to work with.
Well, hold on. Then how do they create the time series? If they create it from a tabular or with a list with a look, if they make it, yeah.
If you create from the tabular and your tabular will have the the column keys, you will have this what we call neo. So then you will have multiple components, and then evaluation at the timestamp will gonna give you association, as you saw before.
I got it.
If you just give a time series with a simple list of values, it's gonna create something which we call the simple time series, which will have a tabular column as the values. And then when you evaluate the timestamps, it's gonna give you an element from this tabular column, which is gonna be a list, or maybe gonna be a number, or maybe a list, depending on what's the type.
So what's the problem? That sounds exactly right to me.
The thing is that you need to that from the user perspective, we need to understand that there are two possibilities. And so when you are presented with just time series, to kind of recognize that you're gonna be getting scalars, or you're gonna be getting association.
Well, then say it in the summary box. But I mean, I don't understand why there's a problem. If you create the time series from a collection of associations, you're going to get the tabular case. If you create it from a list of individual numbers or lists, you're going to get the simple case.
Yes.
There is no problem. It's just that
the issue comes up with transformations.
Right.
What transformation?
Like moving map or time series map, where we operate on values, and we need to kind of
transform
understand
columns and construct columns. And
no, but construct columns are creatures of the tabular world, and you're going to make it a tabular before you do that. So once you've made it a tabular, if you say, okay, here's a question. If you have a simple time series and you say tabular of that, what's got to happen is that you've got to have a default column name for the
Right,
value.
we do. If you
Yes, we
just
do.
scroll down a tiny bit, I think you'll see it.
Okay.
There
we
you go.
Here.
So we use
Timestamp
value as a
value. So we timestamp and value.
Yeah.
Great. So then what? So then if you're going to do transform columns, you make it a tabular first, because we know you have to do that.
Yes.
Yep.
The problem is that then transform columns appends a column as your result. And then suddenly the simple your time series will have two columns.
But I don't understand. There's no problem.
It has to change the
Joshua, there's no problem.
if this
right?
is no problem,
Because,
that's great.
But listen
It's
to the
just
flow.
changing
Listen to the flow of what's got to happen for somebody to be in that situation. Okay. They had a simple time series. They made it from a list. They then said tabular of that. Then they got a tabular. They know they got a tabular. Then they monkey with the tabular and they got another. Then they've got a tabular time series. There's no problem with that.
Okay, great.
If they want to demote it, okay, here's a question. If you had a one column tabular time series with a column named value, does it automatically demote to a simple time series? The answer is
yes, and that's what we want to happen.
Right, but there's
so
no
we
definition
need value
of
as a
that.
reserved name.
Yes, that's fine. So but the whole point is there is no demotion because in fact internally it's stored the same way. It's just for purposes of the way that it returns a sub-value, it does that.
Yeah. But what that means is that when we say you do transform columns, we need to change that value name to some generic name that isn't that reserved name.
I see. Well, that seems like a minor issue. Yeah.
Yeah. Or we just prevent it from working. But I mean, the more I think about it, the more I'm convinced we're better to convert it to a generic name.
Yeah. So we have the generic names component 1, component 2. So that's also the question whether these are the good names.
Stephen, do you think we need one more time for this?
We're going to need one more time for time.
I'm going to have to run for today.
Yeah, I also need to run. I'm 20 minutes late for something else.
Yeah, same here.
This is great. Let's do one more meeting.
Then one more and we'll have it, I think. Sounds good. We made super good progress today. Thank you.
Yep. All good. Very nice work.
Okay.
Okay.
Good.
See
Bye
you
now.
soon.
Thank you.
Bye.
Bye.